Excuse me, I was just meditating on the dividend discount models. I'm sorry, I was in deep meditation. Yeah. Let's continue. The discounted cash flow model. Oh my goodness, this is my most favorite model. A powerful version of the dividend discount models is the discounted cash flow model. Now, there are various versions of the discounted cash flow model. We're going to use the one that concentrates mostly on dividends. Some people use cash flow, some people use earnings. We're going to use dividends because dividends don't lie. The formula is the value of the stock equals the present value of all expected future cash flows. So this looks kind of scary, doesn't it? Well, what does it mean? It means the cash flow in year number 1 divided by 1 plus our discount rate, our required rate of return. And we add to that the cash flow in year number 2 divided by 1 plus the discount rate squared. And then the year number 3, the cash flow in year number 3 divided by the 1 plus the rate to the third power. Now, folks, I promised you wouldn't have to use a calculator other than one that does add, subtract, multiply, and divide. You don't need exponentiation, so relax. We're just showing you the pure form of the model. And it turns out many students like this, and they use it. Most of them don't do it correctly. And I'm not sure why that is. I think they're not even bothering looking at the presentations that I record or reading the book. I think they're just going online and just saying dividend discount model, what does it look like? Oh, okay, I'll do it. But then they don't know what they're doing and they don't do the exponentiation correctly. But some people do, some students do. So I wish you would go through the presentations. I hope you do. I mean, I'm doing them here for you. Anyway, let's say we have a company that has 3 annual dividends of $10 per share and then 0 dividends from then on. So the required rate of return, let's say, is 7%. Remember, we decide what our expected rate of return, desired rate of return, required rate of return, the discount rate is. We decide. So let's try 7%. So $10 divided by 1.07, the dividend in the first year divided by 1.07, plus $10 divided by 1.07 squared, plus $10 divided by 1.07 to the third power, and you have to do the exponentiation first before you do the division, or you're not going to get the right answer, gives us $26.24. You don't have to do the calculations. But how often do companies pay 3 annual dividends and then promptly go out of business? Plus, we keep using this term present value. What does present value mean anyway? Slide 22, the present value. The present value is one of those terms that drive people crazy. It's the value today of a lump sum or a series of payments to be received at some future date. It's the inverse operation, the opposite of the future value calculations that were optional in chapter number 1. We hoped you looked at the results, but we didn't need you to do the calculations. We learned about them they're easy to do. Business 121, Principles of Money Management. So let's say you have $10,000 and you're going to get 10%. Well, the formula, which we're not going to use, is an exponential formula, is 1 plus the rate to the number of years. So 1 plus 10% to 10 years. And that multiplier is 2.254. So 10,000 times 2.254 is equal to $25,940. So the future value of 10% for 10 years, future value of $10,000 at 10% for 10 years is $25,940. Okay, what's the inverse operation? Suppose we know that we're going to get $25,940 in 10 years. And our discount rate, our expected rate of return, our desired rate of return, our required rate of return is 10%. Well, then notice that the formula is exactly the same except it is the inverse. 1 divided by that little messy thing there. And it turns out that $25,940, 10 years from now at 10% is worth to us today $10,000. That is the present value of that future cash flow. I apologize. I know it's a little tricky, but you tell it to yourself. Mouth the words, and it'll start making sense because the calculations are very easy. Present value and future value are just two sides of the same coin. In finance, present value tells us what the future value is worth today. Computing the present value is called discounting. I'm so sorry. I know it sounds kind of dumb, but get used to it because that's the term you're going to hear in the industry. You're discounting that future cash flow back to the present. That's the verb we use. My apologies. So, did the formula scare you with the exponentials and the denominators? Look, don't worry about them. We're just going to use the present value tables. All you do is look it up for the current year, the next year, the year after that, and multiply. So that's why they're called present value multipliers, PVMs, as opposed to the future value tables, which gave you the future value multipliers. So then the formula becomes the cash flow in year number 1 times the present value multiplier for year number 1, plus the cash flow for year number 2 times the present value multiplier for year number 2, plus the cash flow for year number 3 times the present value multiplier for year number 3. Are you with me? You understand? It's simple math, arithmetic. Multiply and add. Multiply and add. Present value multiplier, PVM, is the present value multiplier for year number 1. PVM2, present value multiplier for year number 2. We use the present multipliers to discount the future cash flows back to today, back to the present. So let's do that same example over again using the present value multipliers from the present value table on the class website. So hopefully you'll print this out. We would, in the face-to-face class, we print out a copy of the present value multipliers and use a different color because they're so important. We want you to have them in your hot little hands when we do these problems. So let's say 3 annual dividends at $10 per share and our required rate of return is 10%. Well, now we multiply the $10 times the present value multiplier for year number 1, $10 times the present value multiplier for year number 2, and $10 times the present value multiplier for year number 3. So where do we get them? There's the link on that, and print that out, and here it is. Here's the present value of a lump sum investment. We go across the 10% down 1 year, 0.909. Go across the 10% down 2 years, 0.826. Go across the 10% down 3 years, 0.751. So those are the 3 numbers that we used, right? 935. Did I do the right ones? I think I did the wrong ones. 909. Oh my goodness, I used the wrong ones. I used 12%, didn't I? Which ones? I used 7%. Oh, right, we're doing 7%, not 10%. I don't know, folks. Maybe it's time to put me out to pasture. You were doing 7%, so my apologies. I was pointing in the wrong direction. 7%, 0.935. Year number 1, 0.83873. Year number 3, 0.816. So now we got the right numbers. My apologies. 0.935, 0.873, 0.816. And that gives us $26.24. So what are we actually saying, right? If we require 7%, then $10 that we believe we're going to get in 1 year today is worth $9.35. That's what the present value means. I mean, I'm sorry the words are so strange, but it's actually very simple. What is it worth to us today? If we're going to get $10 in 1 year and we require 7%, today it's worth $9.35. If we're going to get $10 in 2 years, we multiply it times the present value multiplier for 2 years at 7%, and it's worth $8.73. In 3 years, that $10 is only worth $8.16. So the sum of the present values of the future annual dividend cash flows equals our perceived value of the stock. Now you might want to stop right now, pause the presentation, and go back and listen to it again, and speak the words as I say them, because it just sounds funny when you say it at first, but once you've said it enough times, once you've done it enough times, it's really very simple. The calculations are not that hard, folks. You multiply, find the numbers and multiply them. And then we're going to find that we have a spreadsheet that's going to do it for us. So that's later on. So here is the slide that shows you exactly what we did using the correct required rate of return. 7% for the 7% discount rate, required rate of return, desired rate of return, expected rate of return, 0.935, 0.873, 0.816. We multiplied the cash flows from the dividends in year number 1 by the present value multiplier at 7% for year number 1. We then did the same for the dividend payments for year number 2 and 3, and adding them all together gives us the present value of the future stream of dividend payments. Say it enough times and it'll make perfect sense. So, now, what's wrong with this? This is kind of silly. Our example did not take into account that the stock will still have worth at the end of the 3 years. So to make the model more useful, we simply add our predicted market price of the stock at the end of the 3 years. We treat the price of the stock at the end of the 3 years as a future cash flow. I mean, we certainly hope that the company doesn't go out of business after 3 years. So now the value of the stock is equal to the present value of the future dividends, which we already computed, plus the present value of the price of the stock when we plan to sell. What is our time horizon? And again, we use the present value multipliers. As with the dividend discount models we saw in the previous presentation, the model is very sensitive to our estimates and our choice of required rate of return, and hence the results will vary wildly depending on what inputs we give to it, depending on what our discount rate is. So now let's say that the current price of the stock is 125 bucks. We predict that the market price of the stock will be $135 at the end of the 3 years. Now, where do we get this prediction? We can make it up. We'll later on see some services that will give us predictions, and we use our judgment to decide if we think they're full of beans or if they know what they're doing. It's not a precise science. So now we take the year, and what I like to do is I like to write it as a table. I just think it makes a whole lot more sense, and that's what we're going to do when we eventually use spreadsheets. We have years 1, 2, 3, and 3. Wait a minute. Why do we have year 3 twice? Well, because we're going to use the dividends for years 1, 2, and 3, and then the expected stock price of $135 at the end of year number 3. So that's why we notice the present value multipliers for year number 1, the present value multipliers for year number 2, and then the present value multipliers for year number 3 we repeat, because we're getting the dividend in year number 3 and we're getting the expected stock price at the end of the year number 3. So we do those calculations, the $10 times the 0.3935, the $10 times the 0.873, the $10 times the 0.816, and then $135, the predicted stock price, not the current market price, but what we predict the stock price to be, times 0.816, and that gives us a stock price of $136.40. So we believe that the stock is worth $136.40. That's our present value calculation. The stock is selling for $125, so this model is telling us that this is a potentially good investment for us. Now, is it a good investment for us? Well, we got a whole lot more research to do, folks. We just don't go, bingo, okay, let's buy it. No, or no, let's not buy it. No, this is just pointing us in the direction of companies that may qualify as good investments for us. So let's take a look at an example. Here is Pretzels Unlimited. It's not a real company, but I love pretzels. It's currently selling for $22 per share and will pay $2 per share in dividends in 2025. PU expects to increase their dividends to $2.20 in 2026, $2.30 in 2027, $2.30 in 2028. We'll be selling the stock at the end of 2028, and we expect the price to be $27 per share at that time. Our required rate of return is 12%. Well, let's see. The value of the stock is equal to the present value of future dividends and the present value of the stock when we plan to sell. So now, if we assume that we're going to get $2 in 2025, $2.20 in 2026, $2.30 in 2027, $2.30 in 2028, and that the stock price will be $27 at the end of the 4 years, in this case 2028, we go to the present value table for 12%. So let's run over to the present value table for 12%, and here are those present value multipliers: 0.893, 0.797, 0.712, 0.636, and sure enough, we multiply the $2 times the 0.893, the $2.20 times the 0.797, the $2.30 times the 0.712, the $2.30 times 0.636, and notice we multiply the expected price of the stock, $27, again 0.636, because we're getting it in the 4th year. We do all those multiplications, then add all those numbers up, and we get approximately $23.81. So we believe it is worth $23.81 if our required rate of return is 12%. With a market price of only $22, yeah, this is a potentially good investment, because we can buy what we believe is $23.81 of present value for only $22. Does that make sense? Do it again. Do the calculations. You're going to do them manually for now, but then we'll show you a spreadsheet that does all the calculations for you eventually, all right? Not a bad deal. So let's now go to the next slide and put it in a table format. And I just believe that it looks so much easier to understand in table format. Notice, again, in 2028, we're using the exact same present value multipliers because it's the exact same year. And then I think it's just easier to comprehend and calculate. But what we can do is we can simplify it. And let's take a look at slide number 30, where what did we do? We combined the year 2028. We combined the dividend in year 2028 with the expected stock price, the future expected stock price, predicted price in 2028, and we get $29.30 of future cash flow. And so what it does is it removes some of the manual calculations, right? But more importantly, this is so cool, it allows us to use a special spreadsheet function to calculate what is called the internal rate of return, IRR. Okay, what is it? Well, it's a measure of what rate of return we expect to get from this series of cash flows. Now, the internal rate of return includes both positive and negative cash flows. We've just been dealing with the positive cash flows, but when we use this, we have to include the negative cash flows. And someday, when you take an upper level or graduate finance or investment class, you will learn how to manually compute internal rate of return. And hopefully you will not have a sadistic professor who will require you to calculate it manually more than once. We are simply going to enter the numbers into a spreadsheet formula and press the enter key. How's that? In other words, we required a 12% rate of return from Pretzels Unlimited. But what do our numbers tell us it will be our expected rate of return? Well, here it is, dear students. And if you've never used a spreadsheet, relax. They're really simple. They're like giant bingo calculators. Really, you have cells and rows and columns, and it's not that hard. Once you play with them enough times, and they're going to be given to you. And of course, you're going to want to learn how to futz around with them, but they're very, very simple. The internal rate of return spreadsheet formula is =IRR And then we put in the block of values, including the negative cash flows, what we had to pay to get the stock. And then the optional second part of the formula is what you think the value is going to be. You can just leave it as 0, and the spreadsheet will try to figure it out itself. So here are our cash flows, and it's A and B, C, 1, 2, 3, 4, 5, 6. So there's our formula. Equals sign IRR from B2, where we have to buy the stock at $22, and then through B6, where we have our future cash flows, and we put in 12%, but we could have left it as 0 and let the spreadsheet try to figure it out. And so the spreadsheet is saying to us, if you pay this $22 today and you get these cash flows in the future, you're going to get a 14.5% internal rate of return. Now, internal rate of return has some weird quirks that you would learn about it in an advanced finance and investment class at graduate level, but we're not going to deal with those now. Sometimes it gives you aberrant, which is a fancy word for bogus, results. So we have to be careful. But with our types of, with the examples that we're going to use, no, we're not going to get those strange results. So let's take a look at the spreadsheet. And this is what you're eventually going to use, dear students, I hope. Oops, made it real small. Let's make it bigger again. Boom, 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 boom. I wanted 110, 115% is what I wanted. Boom, boom, boom. Okay. So now, what is it doing? We put in the year, and then it calculates the rest of the years. And we put in the cash flows for year number 1 to 2025, year number 2, year number 3, year number 4. We put those in, and notice that in the year number 4, we added the $2.30 dividend plus the $27. And let's back it down a little bit so we can see that we also put in the current price of the stock. I have to move over a little bit. Current market price and the required rate of return. And the cool thing is, if we just want to change our required rate of return, all you got to do is type in the required rate of return. The spreadsheet does all the work for you. So we put in our current market price, required rate of return, the year, and then the cash flows. And it calculated the present value of the stock for us. So yeah, see, do it manually a few times, and then a few times more, and then a few times more, till you thoroughly understand what you're doing, and the verbs and the words don't get you all confused. And then here's a spreadsheet for you to use. And there are some with 3 years, there are some with 4 years, some with 5 years. And we're going to talk about why we don't go anywhere farther than 3 or 4 or 5 years. And notice that the spreadsheet will also do the internal rate of return for us. It says, oh, you told it that the market value is $22, and that's a negative. That's why it's in parentheses. And then here are the positive cash flows from the first page, the first other sheet. And it says 14.51% is the internal rate of return. Very cool. Now I used, I put an extra cell in here, so it's actually C4, an extra column. I'm sorry, you don't see it, but I started with column B. I have a tendency to do that and make column A just blank. But column C4 through C8. And that's what that formula says. See, C4 to C8. And then again, I put in the 12%. I didn't have to. I could have left it 0, and it would have done it. But see, it says rate guess. what you think it's going to be, and then let it decide. And sometimes it'll come back and say, I can't figure it out. Especially if you have some strange numbers in there. It'll come back and say, sorry, I can't do it. And that's you would learn more about that in an upper level class and a graduate level class. And if you're really interested, contact me, and because I can talk about this far longer than any reasonable person would ever want to listen. Okay, is that cool or what? That is so cool. Do it enough times on the worksheet. Remember, worksheet number 1, worksheet number 2, assignment, exam. talk to yourself about what you're doing when you're doing it. I'm calculating the present value of this future stream of income. I'm using the discount rate of 7% or 8% or 9%. And then you will never you'll be able to do it just like walking or riding a bicycle. And not the cool thing, but the very important thing is you have to learn how to do these. If you don't, it's very bad for my self-esteem. You cannot leave this class without knowing how to do these. Because they're going to be on exam number 2, they're going to be on exam number 3, they're going to be on exam number 4, and they're going to be on the final exam. Yeah, okay, I gotta calm down here. My blood pressure's going up. All right, so now, example number 3, slide 33. Genes or us? You've heard of them, right? They're a biotech company based here in San Diego. And they're going to cure baldness. Or, I don't know, cure hoarseness, whatever. They're currently selling for $21 per share. They pay no dividends. In fact, their earnings per share are negative. But we believe that Genes or Us will sell for around $50 in 5 years. Our required rate of return is 13%. How can we determine if this is a potentially good investment? Well, with no dividends, which model can we use? We can't use the Gordon growth model or the zero growth model because they would just return 0 because there's no dividends. But the discounted cash flow model we can use because we can use the future predicted price of the stock as a future cash flow. So here the formula becomes value of the stock is equal to the present value of the future dividends plus the present value of the price of the stock when we plan to sell. Well, what's the present value of 0 dividends? 0. Okay, so that's very easy. You don't need to do the left side because it's 0. But the expected price of the stock is $65. I mean, this thing is coming up because I made the zoom small. I'll make the zoom smaller again real fast. Get it out of the way. Okay. So we use the predicted price of the stock, $50, times the present value multiplier for 5 years at 13%. So let's go find that. 13%, 5 years, 543. So we multiply the $50 times 0.543, and that tells us that the stock is $27.15. So unlike the other dividend discount models, the discounted cash flow model can still be used if there are no dividends. We simply treat the expected future price of the stock as a single future cash flow. Now, is this cool or what? Yes, it is. So you can put a value on what kind of return you're going to expect from the stock if the capital gains are what you think they're going to be. Right. As we said, are we going to be able to predict that? No. In fact, we're pretty much sure that we're going to get the number wrong. But it still allows us to think about what kind of rate of return we expect from a more speculative issue. That's the wonderful phrase they use in the value line. So are you starting to see that a company that's been making pretzels since before World War I is a very different type of investment than a company that's trying to create the next drug that's going to cure baldness that might wind up making your liver into pate? Yeah, all stocks are not the same. And I'm not trying to keep you from investing in a company like Genes or Us, but we just want you to have your eyes wide open that this is the kind of company that can turn $1,000 into $50,000 or 50 cents. Okay, now let's apply the two spreadsheets to Genes or Us. Remember, the current market price is $21. We expect the price to be $50 in 5 years. It pays no dividends. So the discounted cash flow model here gives us 0, 0, 0, 0 because there's no dividends, and then $50 in 5 years. We multiply that times the 0.543, and that gives us $27.15. The internal rate of return says, look, we pay $21 our initial cash flow. We don't get any cash flows from dividends, but at the end of the 5 years, We expect the price to be $50. We type that into the internal rate of return, B2 through B7. We give it a 0, saying, oh, we don't know what it's going to be. And it's saying if you pay $21 now and get $50 in 5 years, you're going to get almost a 19% return on your money. But it's just a much more aggressive, much more dangerous investment, isn't it? Yeah. Now, as I said, you cannot leave BUS123 without knowing how to compute the Gordon growth model. Please. And the discounted cash flow model. No, if you don't, it's bad for my self-esteem. They're going to be on exam number 2. They're going to be exam number 3, 4, the final exam. So please learn them now. Study the worksheets. Contact me for help. Do it. Do it now. And I really wish you used the present value tables first. If you want to use the exponential formula, fine, but make sure you do it correctly. Okay, anyway, slide number 35. And folks, this is just the beginning. This is just the beginning of your, exactly, it's just the beginning of your journey into researching different companies. Because there are many other models out there. The residual income model, which is basically the same as the Gordon growth model, but it uses earnings instead of dividends. The free cash flow model, which uses cash flow, and how is cash flow different than earnings later, chapter 5. The price ratio models, which use various price ratios, estimated growth rates. There are many valuation models. You have the rest of your investing career to explore them. Please contact me when you find one that is better than the discounted cash flow model for dividend producing companies. One of the best models for growth stocks is the betterinvesting.org stock selection guide. And we should take a quick look at it at the end of the semester. Gotta fix that. It's in the appendix in the book. Yeah. And hopefully we're going to, after you're done here, or maybe before, we're going to point you to the group called betterinvesting.org. Awesome group. If you are at all involved in investing more than just mutual funds, I mean, if you really want to choose individual stocks, you owe it to yourself to join an investment club and learn while you earn. I'm sorry, earn while you learn. Boy, oh boy, making all kinds of mistakes here. Yes, they're a great group. In fact, I'm a volunteer director for the Southern California group, which is called the Golden West chapter of betterinvesting.org. And so I'll be giving plugs throughout the semester. We meet on first Friday from 5:30 to 6:30, 5:30 to 6:30, and for just to get together. And then we have various, but we're not the only ones. There's chapters all across the country that have various meetings and seminars and the like. So check us out. All right, slide 36. Okay, Piano, this is all great, but just where are we supposed to get all this historical information anyway? And just who decides what next year's earnings or dividends per share, the dividend growth rate, etc. are going to be, let alone the expected future price of the stock in 3 to 5 years? Well, before the internet, this information was not readily available. You would ask your broker for it, you go to the library, or you would use one of the trusted information sources available in the securities industry, and traditionally the most respected source was the Value Line. My favorite. They've been around for over 90 years, folks. And when we come back, we will see how we can use the Value Line to populate our models and tilt the odds in our favor towards prudent, long-term, successful investing. Dear students, you are now official investment gurus. We're so proud of you. See you in our next presentation when we take a look at the Value Line, a sip from the financial fire hose.